Hello, everybody. Here we are, 4.2 linear relations. Just a few notes before we start. So, a linear relation, let's say, relates two variables. It's a relation or equation that creates a straight line. Missed an A. Straight line graph. Let me do that a little bit better. And two more things I want us to know, or I want you to write down, is that the x-axis is horizontal and the y-axis is vertical. I always remember horizontal is left to right because it's like this, just like the horizon. Okay, if you see a beautiful sunset, right, the horizon goes left to right. And vertical, I don't know how I can remember vertical. I always think about, you ever see those videos of those guys jumping super high, like in the NFL or whatever? Anyways, vertical, up and down. So let's look at a few tables and determine whether or not they represent a linear relation. So a linear relation needs to increase on each side in like the same pattern. So this one is going up by 1 plus 1. Okay, that's the same. And this side is going up by plus 2, plus 2, plus 2, plus 2, plus 2. So yes, because they increase at a consistent rate. Like linear, you can think about it as. And this one, this side goes up by 2 each time. Okay, that's promising. But this side goes up by 2, but then plus 4, and then plus 6, and then that's got to be plus 8. So let's say no, because it does not increase by the same number each time. And maybe I should not say at a consistent rate. I should say by the same number each time. So sorry if you've already written that down. Maybe I stopped you. Increase by the same number each time. And I'm going to graph these two and I'll show you what this linear relation looks like and what this one over here looks like. So this, remember, is our x-axis. It goes horizontal, just like the horizon. And this one is our y-axis. It goes up and down. So the first one, when x is at, oh, this is so small. Let me zoom in. Okay. When x is at 1, y is at 3, so 1, and then 1, 2, 3, 1, 2, 3. When x is at 2, y is at 5, 3, 4, 5. When x is at 3, y is at 7, 1, 2, 3, 4, 5, 6, 7. When x is at 4, y is at 9, 8, 9. And when x is at 5, y is at 11, which is just 1 above there. So you can see it makes a straight line and would go on that way forever and down that way forever. Let's look at this one though. When x is 1, y is 1. Okay, so 1 and 1. Remember, this is our x, this is our y. They go positive 1, 2, 3, 4, 5, 6, 7, 8 to the right and negative to the left. So this is negative x over here. This is negative y down here. This is positive y up here. Then our next one at 3, 1, 2, 3, and 1, 2, 3. Okay, so you can't really see yet. Could be a line, who knows? But let's try the next one at 4, 5, and 7. 1, 2, 3, 4, 5, 6, 7. Okay, you can kind of start to see it take shape into this curve that we're going to get. That was 5. Now we're at 7. 1, 2, 3, 4, 5, 6, 7. And up 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, up here somewhere. So you can see it's taking this curved shape rather than the straight line. Okay. So let's move on to the next one. You can copy that down if you can. So these are our positive x's over here. These are our negative x's over here, negative y's and positive y's. So for number 2, each table of values represents a linear relation. So it represents a linear relation. It's telling us that. And what we know to be true is that it increases by the same amount each time. So here we see that it's plus 4. And since we know it's a linear relation, we know it to be true that this would then also be plus 4. So 22. And this one before it would have been plus 4. So you can kind of think about it as minusing 4 to 10. And this one would be 6. So you can use it to figure out the other ones based on this information that we know how it's going to react. So explain your reasoning. I knew it would increase by plus 4 each time. Okay, so as y is going up by 1, we see that, as x is going up by 1, we see the y is going up by 4 each time. We know that to be true because we know it's a linear relation. It told us that. Let's do number 3. So create a table of values for each linear relation, then graph the relation. So use the values x from -2 to +2. So let's go -2, -1, 0, +1, +2. So we went from -2 to +2. And now let's find out our y's. The way that we can do that is by inputting our x values over here and using what we know, as I say, to find out what we don't know. So when we first input it, y is going to be equal to -2 plus 4. So that's going to be +2. If we do -1 in there, y equals -1 plus 4, we would get a +3. If we put in 0, we're going to get 0 plus 4, which is 4. Next, if we put in 1, we're going to get 1 plus 4, which is 5. And now you can kind of see the pattern. We're going to be at 6 this time. And now we can graph it. So let's start at -2. So this is our x. This is negative x over here. This is y. This is negative y. So we're starting at -2 and we're at a positive y. So we're right there for our first one. Next one, we're at -1x and we are at positive 3y. Now when we're at 0, so the axis itself represents 0. So this is when y is 0 and this is when x is 0. So 0 and plus 4. Then we're looking at 1 and plus 5 and 2 and plus 6. So there's our graph. Going to go like that. Going to go on forever in each direction. Okay. And number 4, a computer repair company charges $80 for a service call plus $50 an hour for labor. So this is kind of what we were doing in 4.1. We're using a word problem to make an equation. And so what do we have here? Well, let's go through the question first. I'm sure it's going to ask us to make an equation. So first, create a table to show the relation between the time of hours for the service call and the total cost. So I didn't give myself much room here, so I'll do it right here. Let's go cost and N for number of hours. Sure, it says right here, let N represent the time. So let's do a few. I guess the cost would be, $80 for 0 hours. I mean, I don't think that's going to happen. So I don't know if you'd even bother with that. But let's do $80. Oh, my bad. $80 plus $50 for the first hour. So that's going to be $130 for 1 hour. For 2 hours, we would pay $100 for the labor and $80 for the flat rate. So that would be $180 for 2 hours. Let's do one more. Let's do 3 hours. So that's $150 for the hourly rate plus the 80 gives us $230 for the cost. So that's A right there. Let's do B. Is this relation linear? Justify your answer. I would say yes. Yes, because it increases by the same number each time, as this goes up by plus 1, plus 1, plus 1. This goes up by plus 50, plus 50, plus 50. And let's do C. Let N represent the number of hours for the service call. C represents the total cost in the dollars. Write an equation. So the cost equals, remember, $80 is our flat rate. So we're going to pay that no matter what. And it's going to be in addition to $50 per hour. Okay, so this is our constant. There's always going to be $80. The $50 is the one that changes based on the N, the number of hours. So let's do our last one, D. How much will a 7-hour service call cost? So we are looking for cost. That's our unknown. So we'll keep that C there. And let's just put in 7 into our N. 50 times 7. C equals, let me do this in my calculator. I think it's 350 plus 80, but